bit. So there are concepts like what is work done. Okay, so there are some guidelines. These guidelines are not hard and fast rules. Okay, it is not that exactly the same value will be followed everywhere and every time. Okay, because we already know that these things are very site specific. Okay, where we are doing our project, what type of skilled person we have in that area. So all these things are the ultimate uh, cost, the number of labors required, etc. So for example, if we are doing something in a city, then we have some skilled people. We are uh, having the options of skilled people our project, and we expect, say for example, one labor to lay 500 bricks in a day. That can be a standard value. Okay? This is expected, but this will vary from place to place, from time to time. Okay, so we have to have some engineering judgment and experience how we deal with these numbers. Okay, how we estimate for the amount of labors required, because material required is almost fixed. We can calculate the materials required from our specifications and dimensions, okay, of our building, of our requirement. We can do that. But what will be the labors required? Because it is dependent upon those people, how skilled they are, okay, how experienced they are. So it will vary from place to place, from time to time. Okay. So there are some guidelines given by National Building. Then that guidelines are to be followed, or we have to go through those guidelines and have an idea. And based on that, and depending upon the conditions on the field, we will have to estimate for the labors and materials ultimately. Then I hope we have gone through this introductory note, and now we are going into see some numericals. Okay, so the first numerical is cement concrete work. We are doing PCC work in the ratio of 1 is to 1.5 is to 3, that is M20 grade of concrete, and we are asked to find out what is going to be the rate for this work per cubic meter of work. What is going to be the rate? And we have to do the calculation for 10 cubic meters of work. Okay, so we have to find out the materials and labors that are required for 10 cubic meter of work, and then finally we have to find out what is the rate for 1 cubic meter of work. That is what we are asked to find out. Now, the first thing, if we are going to have 10 cubic meters of PCC concrete, then how much materials we will be requiring. Now here what we are doing, we are applying one shrinkage factor. Okay. Now why this shrinkage factor is being used? Now this value is 1.52 to 1.57. Okay. At some places we will be seeing 1.52 is being considered, and at some places 1.55, or at some places 1.57. Here we are going with the largest value. Okay, but other values are also fine. So why we do that? Suppose we have to prepare this much amount of concrete. Okay, then if we are taking some stone aggregates, okay, obviously these stone aggregates will have some pores, some voids in between them, right? And the final aggregates will go in between these voids, fill up these voids, right? Then the fine aggregates will also have voids. And then what will happen if we mix cement there? the cement will go into the voids of those fine aggregates. So what will happen? It will shrink. Okay. So if we take materials, say this is coarse aggregate, this is fine aggregate, and this is cement. Okay. For example, and the resulting concrete won't be exactly same. If we add them up, we won't get the exact same volume of concrete. Are you getting the point? What will happen? The fine aggregate will go inside the coarse aggregate, and then their cement will go inside the balls of fine and coarse aggregate. So when we mix them up, this is going to reduce. Okay, this is going to reduce. Say for example, finally, because it is going inside the pores or voids, we'll get this much amount of concrete ultimately. Therefore, if we want this much amount of concrete, then we have to take more materials, okay, more dry materials, mix them up, then only we will get that value. So that is shrinkage factor. Okay, this one. Therefore, if we need 10 cubic meter of PCC work, what we are doing, we are multiplying it with this 1.57. That means we need 15.7 cubic meters of materials. Okay, and then that 15.7 cubic meters of materials, from there we have to do the calculation how much cement we need, how much fine aggregate we need, how much coarse aggregate we need. We are given the ratio 1:1.53. So the cement is one part that we know. So 1 divided by 1 plus 1.5 plus 3. That much we already know, that much we have the idea, right? So this is the total 15.7. Now we get 2.85 cubic meters. Now if we divide 2.85 by this value 0.0347, we get what is the number of bags of cement required. Getting this value? We are getting this value from here. Density of cement is 1440 kg per meter cube, and we know that one bag of cement weighs 50 kg. So if we divide 50 kg by 1440 kg per meter cube, we will get this value. That means this is the volume for one bag of cement. Okay. So we need 2.85 meter cube. For one bag, it is 0.0347 meter cube. Therefore, we are dividing 2.85 by this value on unitary. I hope that's clear. Then, for fine aggregate, what is 1.5 part? Similarly, 1.5 divided by 1 plus 1.5 plus 3 multiplied by the total volume, we get what is the fine aggregate required. And similarly, for coarse aggregate, which is 3 part, we get what is the required. Okay, now cement. After that, we go into the rate analysis. Okay, we will multiply the quantity with the rate. Now this rate, from where we will get this rate? We will get these rates from schedule of rates that are published by the department. Okay, so every state department will publish their schedule of rate, and this schedule of rate will be updated from time to time based on the prevailing market condition. And what I want to say, and for our case, what we are doing, we are taking a model SOR, okay, that I prepared. I will give it to you, and we will do our calculation based on that SOR only, because we are people from different states here. So I combined some values looking at different data, and we took one SOR. When you do the project at a certain place, you have to follow the SOR of that place. Fine. So first is cement. Now we are going by bags of cement. Now this, we need 82 bags, and 400 is the rate per bag, and we are getting this value. Now the cement can be measured in bags. It can also be measured in metric tons. Okay, so we will see that later how to do that, but in this numerical we are doing it by bags. We need 82 bags. What is the cost per bag and what is the total cost for cement? Okay, then sand. In this numerical, it is not mentioned, but as we progress, we will mention it, what type of sand we specifically need. Okay, is it a fine sand? It is a coarse sand. Okay, the rate will be different for fine sand and coarse sand. Then it is what type of stone aggregate it is. Okay, is it a river stone? Is it a working stone? Okay, what is the size of this stone? These things will have different rate. We will see it in the schedule of rate, and according to that, we will take our prices. Okay, so we are going with stone aggregate 20 mm, and this is the price from the schedule of rates. This cubic meter of work, this much cubic meter of sand we need, so we're just multiplying it and we are getting the total cost. Then labors, what is the labors required? Okay, now in that task or work done, we saw that one mason can do around 5 cubic meters of work, PCC work per day. So definitely we will need two masons, okay? And then to oversee this work, we require 1/3 of head mason. What does it mean? That means a head mason will be able to oversee the work of 30 cubic meters of uh, PCC work. Therefore, we are writing for 10 cubic meter it is 1/3. And then what is the rate? Multiplying, we are getting what is the cost. To mason, what is the rate? Multiplying, we are getting what is the cost. Then these mazdoors and builders, we are getting these values from our idea based on those tasks or work turnout. Okay, you have to see that once again, and then based on that, we are getting this how much mazdoors will be required, how much visting will be required, how much cooling will be required, and then form work and other these miscellaneous items. These are based on our experience. Okay, these are based on our experience. So these things are also based on some of our experience, because these things won't be exactly same, or it is not going to be possible to make these things exactly same as given by that guideline, because these things will vary from place to place, from time to time. Okay, so how much mazdoors will be required? Around 8 will be required. How much fisting will be required? Fisting is that person who will do the water works. Okay, they will bring the water, they will mix it, and they are also going to be required for the curing works. Okay, because they are also required for the curing work, that is why we require it. If not for curing, this number would have been less. Okay, 3 persons, around 3% would have done the job, 3-4 persons would have done the job, but because we also require them for curing, we are considering 8% multiplied by the rate, and we are getting the cost. Okay, this number is slightly more than required, and then uh, cost, and then finally the total one. Okay, form work, we know form work. So for form work, we will have to buy the items and reason TP. This is called tools and plans that we may be required during the course of our work. We do not have, we may have to buy. Okay, we may have to hire some item. For that, we are taking around 800 or 1000. You can consider that. This is a total cost coming of material and labor. Then we have to add a water charge. If the water that we are using in our project is charged by the municipality, therefore we will have to add some percentage of water charge. Okay, 1.5 percentage of the total cost of material and labor. We get this value. Then we have to provide a suitable percentage of profit to the contractor. We are taking about 10% here. Okay, if it is not mentioned in the problem, it may be mentioned in the question also, because this will vary around 10%. It can be more than 10% also in some places. So there we are taking here. So this much is the profit to the contractor, and finally this is the value because we did our calculation for 10 cubic meters of work. Therefore we are dividing with 10 and we are finally getting the value for 1 cubic meter. Okay, so this is the way that we have to do the rate analysis. This was for PCC in a given rate. Then this will be different for 1:2:4 concrete. This is going to be different for reinforced concrete, because that we have to do the calculations for reinforcement also, right? This is going to be different. Okay, so that's that way we will go forward. I have to do the calculation for bricks. Okay, how many bricks we require in a 1 cubic meters of work. Okay, so what do we have to do? How do we have to do that? We know the size of the bricks, right? We know the size of the bricks. What is the standard size of bricks? We will say this is 90 centimeter into 9 centimeter into 9 centimeter. So if we are doing masonry work, we have to apply a mortar on the brick, right? So after application of mortar, what we say, the size becomes 20 centimeter, 10 and 10 centimeter, right? Fine. So if we divide 1 cubic meter with this size, okay, the volume of one brick 0.2 multiplied by 0.1 into 0.1. This is the volume of one brick with the mortar that will be required. If we do that, this comes out to be 500. Okay, so this value we should remember. So that means that we have to use 500 bricks at least for 1 cubic meter of brickwork. Right? Now this value should be increased by some amount, because there will be some losses at the field. Some bricks will break, some we have to break intentionally because we are using the closures. Okay, so all these kind of things. But as a general, we will say that we require 500 bricks for 1 cubic meter of masonry work. Fine. Then just like we used a shrinkage factor 1.57 in case of concrete, we will have to use another shrinkage factor in case of plastering if we are doing some mortar, okay, masonry work. So if it is, you already know that the brick walls, okay, may be uneven. Okay, the joints, the mortar joints may be uneven. So what we have to do when we do the calculation, we assume the square, whatever here is the grade. Okay, say we say this is a grade is 4 meter, height is 3 meter. So 12 square meter. 12 square meter of plastering is required. Thickness is, for example, 12 mm. Okay, that way we do our calculation. That is the total amount of plastering work required. But what we should also be considering that there will be some uneven spaces in the brickwork. There will be some uneven joints of mortar. So before we get an even surface, we have to apply mortar on the uneven surfaces, uneven brick joints also, to make it an even surface. And then after that we have to apply a 12 mm of plastering. So therefore we will require some extra material to make the surface even. We will require some extra material to be applied in the joints so that we have an uniform surface, and over that we will apply our plastering. So first, we have to increase whatever is the material required. We have to increase that material by some percentage, say for example 20% or 30% for uneven surfaces. Okay. If the thickness is smaller, then we will consider a larger value. If the thickness is higher, we will consider a smaller value. That value we have to apply, and we have to increase the materials required if the brick surface is uneven. There are some uneven mortars and joints, fine. And then again, we have to increase it by 25 to 30% because of the shrinkage factor, because the fine aggregates will have voids and cements will go inside the fine aggregates and will shrink eventually. So we will have to consider higher value. So in case of mortar, what we have to do, first we have to increase the values for what? Uneven surfaces, and then we have to increase the value again for shrinkage. Okay. So yeah, this is shrinkage. So for uneven ones we have to do, and for shrinkage we have to do. This will be clear when we do a numerical. We'll do it in the next class.